Okay, on this first one, biggest deal is making sure you remember the negative gets distributed to both parts. The denominator is easy. It's going to be out of 5. It's just the top has to be like really careful. This minus x and this regular x, they're going to cancel each other out. That leaves you just this 7 and a negative and another negative 4. That means plus. 2 negatives on the 4 means plus 4. So final answer 11 over 5. Raise your hands if you had that one right. Virtual hands too. All right. Seeing most of you guys got that. John Piper, can you just give me a virtual hand that I know you're with me? Last call for John. Okay, thank you. All right, next one is letter B. On letter B, be ready, online kids, to give a how do you do this. What's a good denominator? We're going to go with Dale and Thomas. What's a good denominator for these guys? Dale, you with me today? Oh, she looks like she tried an answer and then it wouldn't work, so she's going to come back. Angelina Fisher, can you tell me what a good denominator would be for these two?
14.
Okay, good. And to get it to have a 14 denominator, Luke, you'd have to multiply the top right by something.
You have to multiply top right by 7 over 7.
7 over 7, very nice. The top left, Martina, what would be a good thing to multiply the top left by?
2 over 2.
Very nice. Now, as I multiply this out, I'm going to go in the room. Alban, on the left side here, what is it out of 14 on the left side? 2x plus 14, very nice. On the right side, Elisa, what? There you go, 7x minus 28, very good. And then Bertha, when you put it all together, I know it's out of 14, and I know you know that, but what's on the top? 9x, and when you put those two together, okay, then you got the negative 28 and the positive 14, and she's recalculating. Negative 14. Can anybody verify you had negative 14 on the top? Okay, now that was negative 28 and positive 14, leading to a negative 14. Now, can you simplify it further from there? Alban, what do you get for a final answer? Yep, it just even simpler than that. Negative 1. Now, I have a lot of people like staring at the board here. Is there something wrong here? It's possible that there is. I don't think so. Yes? Oh, the 2x and the 7x need to go together. Okay, sorry. That would have been negative 1, except there is a 2x somewhere. That's why everybody was staring at the board. All right, so should we put the 2x and the 7x together and make 9x? There we go. Now, this brings up an important point. If you see something like that, and if you're on your test and you're like, wait a minute, something's going wrong here, stop, because you very well could be making a mistake. And go back and like double check it, because you saw a math teacher right there make a mistake. This happens. Next part is, a lot of kids are going to think that that 14 cancels. It cannot cancel, because it's not part of a multiply. If it had been 9x over 3, then you would cancel stuff. You'd make this 9 into 3 times 3, cancel, cancel. But that's multiply. When it's like this, you cannot cancel those 14s. It would be like this, 7 minus 2 over 2. If you're ever like not sure, can I cancel this or not? Make it with easier numbers, and then ask yourself, can I cancel those 2's? Well, that'd be like 5 over 2. Is that the same as 7? No. So you can't cancel like that. That's how you can tell if you can or can't cancel. So try sticking some irregular numbers in there and see if they can cancel. Now, if it was 7 times 2 over 2, that'd be 14 over 2, which is 7. So yeah, I can cancel those. So when they're multiply, you can cancel them. When they're add subtract, you can't cancel them. All right. Now let's get over to the a little more complicated kind. x squared plus 6x minus 7. That factors, by the way, and if you can factor it, you should. And I'm going to make this a divide because I'm going to skip right over multiply because I think you guys know multiplying fractions is so easy. You just multiply across the top and bottom. But if you divide, you got to remember one other thing first. All right, and then this is going to have an x plus 7 here, and it's going to have a 4 here, and it's going to have an 8 here. Everybody try this divide of fractions. We've practiced it a lot. I'm hoping you're feeling pretty good about these. Victoria, which of the two fractions is going to get flipped?
The second one?
Yep. The first one just drops straight down. And then we call it drop, switch, flip. Switch it to times. And then, like you said, this one flips. 4 on top over x plus 7. But I made a classic mistake. I didn't factor it. And if you can factor it, you should. Bertha, did you figure out what it factors to? Did you figure out what this factors to? It would. Plus and a minus. Very nice. 7 is positive and yes. Did it on the spot. Nice job. Alban, what cancels? Hint, more than one thing.
7x and 4 and 8.
All right, this x plus 7, yes. And the 4 and the 8 will do some canceling. So here's how I like to do that. If you can factor it, you should. I factored the 4 into 2 times 2. I factor the 8 into 2 times 4. And then the 2's cancel. And then I look to see what I have left. Ooh, I have this left. I have that left. On the top, I have 2x minus 1. Can you leave it factored like that? Yeah, because if you can factor it, you should. And then I write it like this, and I hope you would notice, oh, wait. Jack, see something else we should do? Into 2 times 2, and then what happens? Boom, boom. Final answer, x plus or minus 1 over 2. Put your real or virtual hands up if you feel like you could do that on the test tomorrow. Are you feeling confident on that kind? All right. So, next, do you want more practice on that one? If anybody wants more practice on that kind, I'd be willing to. You just got to either raise your virtual hand or raise your real hand if you want another practice one like that. All right, I got 3, 4 people that are asking for another practice. Let's do one more like that. X squared plus 5x, let me think, plus 6 all over x squared minus 25. Those you got both little factoring problems. Then divided by wait a minute, I screwed up. The top one won't factor, so I don't want to do that. I want to make this a minus 6. Sorry about that. Make the top over here, make that a minus 6. And now it will factor. Jack, help me start by factoring that first one.
There would be an x minus 1, there would be an x plus 6.
Yep. You got it. Because there had to be a negative in it because there was a negative in the problem. And if I multiply yours out, I get x times x makes x squared. And here's the key part. I'm making an upside down smiley face because, you know, there's not much room underneath it. But 6x for the outsides and negative 1x for the insides. And that makes our 5x. Then, Jack, what's on the bottom of that one?
The bottom would be factored into x plus 5x minus 5.
Yep. Good job. This becomes a times Quinn.
You flip the equation.
Nice. Let's see. Veda's gone today. Bennett Worry. Tell me something that cancels. Because there's one on the top and one on the bottom. You're right. Elbon, last thing that cancels. And now, you just look and see what's left. Tommy Radebach, what's left and therefore is the final answer? I think he's gone, actually. Sorry, not seeing him in the chat anymore. So, all right. You guys let me know if he shows up. He's absent. My bad. All right. Victoria Seeley, what's left as your final answer? I'll try Victoria again in a minute. Last chance for her later. Let's go with Nick Richards. Oh,
I'm sorry, my thing is really glitchy.
okay, Victoria, can you just tell me the answer?
Would it be x plus 6 over x minus 5?
Yep. Okay. So moving on. There's another whole part to this test, and it's about these. Y equals 1 over x minus 4 plus 3. Now, I hope you remember the parent graph. I'll remind you. It kind of looks like this. And then it has dotted lines here and here, and those are called asymptotes. Okay, so this one's been moved, and you need to be able to know this is right. If you haven't got this down, you need to take notes now, because this is so easy if you just know which way it goes. That whole graph just goes right 4 and up 3. They always are opposite of what you would think when they're on the inside. This red area I'm put in parentheses, that is the opposite of what you would think. That seems like it should move left 4, but it in fact moves right 4. Okay, so now if I was going to regraph this and say here's the parent one and then here's the new one, I take these 2 points, these 2 I'm making in red, and I move them and the asymptotes with them to the right 4. See how I just moved the asymptote to the right 4? That red one. And then I need to move it up 3. So I'm going to take the other one, I'm going to make it green. And that's me moving the asymptote that goes horizontally up 3. Okay. So now, how do you put in the actual graph? You put a dot here and a dot here, because those points, when you stick in the numbers, would make, you know, the equation work there. And then I just draw a little line, it gets closer and closer and never touches. I use the example of the little kid getting his tongue close to a super cold pipe outside. They might dare themselves or dare their friend to touch it, but they don't actually touch it because they have heard what happens. Okay, so that would be an example of one. Is there any part of that you're afraid of? You're like, oh, how did you do this part? Any parts that you need help on? So I'm willing. All right. Yes.
Do the lines need to be perfect, like exactly?
Perfect? Of course not. There's no perfect in the world. No, even if people that think they're perfect, they're not perfect. So, do we have to know like where they are? Yeah. And this is one of those things I want to make sure you get. What's the name for this green line? Well, it's either x equals 3 or it's y equals 3. That green 3 there. It's really easy to get confused. So here's how I like to think of it. This is the x-axis and this is the y-axis. What does it look more like? The x-axis. But then you don't use x equals 3. You use what? Y equals 3. To me, that's the easiest way to think of it. Is it runs across kind of like the x-axis. And the x-axis is where y equals 0. So anyway, if you rather think of it a different way, that's fine. But you got to get it straight. Which one's which? Then how about the red one? Well, if the horizontal ones are y, the x ones must be the other ones. This must be x equals something. And I had a 4 here, so it's x equals 4. All right, let's see if you really got that. Here's another picture. Here's dotted line. And the dotted line is going to be at, that's going to be at 2 right there. And then this blue dotted line is going to be at -5. Would you name them? You have to be able to give me an x equals this and a y equals that. Get them straight. Which one's which? If you're baffled, think about which one's the x-axis, because the x-axis is where y equals 0. So here's the x-axis, and that's where y equals 0. So this is a y equals -5. Who had it right? Raise your hand if you knew which one was the y one. Y equals -5. Very nice. And then the x-axis must be the other one, too. Okay. Now let's do one where you actually just make a graph. I don't have graph paper to give you, but just try to be somewhat accurate and try to graph this. Y equals 1 over x minus, no, let's make it plus this time. X plus 1 minus, it seems a little too much to move it down. Let's just move it down 4. Minus 4. Everybody graph what that would look like. We are almost done, and then you'll have time to take this practice test and check it with the key. Now, I'm going to start by graphing the parent one to just kind of remember how that looks. You put a dot here at 1, 1, and a dot here at -1, -1. That's what they all are supposed to kind of look like. But this one's been shifted. One of your questions could be, which way was it shifted? So Vikram, if I had to say right or left, what do you say? It was shifted left. 1. I totally get that. Feels like it should be right 1. But on the inside, it's the opposite of what you think. Now everybody write down what the other direction was that it was shifted. Elisa, do you think it's up or down the 4? Down 4. Be careful on that inside, because if I've seen people make mistakes, it's almost always here. And I get it, because that feels like it should be going right 1, but it's actually going left 1. Okay, so now how do I actually do this? If you can ignore the one on the screen, then I'm going to do this other one right over the top of it. This is me moving the asymptote left 1. And then this is me moving an asymptote down 4. And then I'm going to do this in green. I'm going to put a dot here and a dot here. And then draw my lines like this and like that. How many of you feel like this is easy money? Easy problem. Okay. I went left 1 and I went down 4. The new one is the one with the red asymptotes and the green lines. Now, last time, again, this is so simple. Some kids just going to put x equals where they should put y equals, and they're going to lose points. Would you please label the asymptotes on this new graph? Those red asymptotes, label them. What's this one? What's this one? Label them on your picture. Right here. Is this x equals or is this y equals? X equals what and y equals what? They always have asymptotes. There's always going to be an x equals. There's always going to be a y equals. And you'll know what the numbers are. It's just, will you reverse them by accident? And say x where you should have said y. Lily Studensky, the vertical line, the one that goes up and down, what do you think that one is?
-1.
Okay, but is it x or y? Think carefully because that's the part everybody messes up. All right, it's running like the y-axis, so you're right, it's x equals -1. Very good. And Mr. Nault, the last one? Y equals -4. Yes. That's it. Done. But isn't this one like the x-axis? Yeah, if it's like the x-axis, then it's y equals something. All right. You have one more chance to learn everything that you'd want to know, and that is on the review sheet that I have put. Actually, you can't see it yet. I got to open it right now. So everybody, please, in a moment, you're going to refresh your Schoology, and a worksheet will come through, which is like a practice test. These are really nice. When you get to high enough level math, they don't give you practice tests. But so honestly, you should really be like, oh, this is so nice to know exactly what he wants me to know for the test. So this is called the U11 practice test. And it's there now. Open it up, and if you got the right one, it starts with 2x plus 1 over 4 plus 3x minus 7 over 4. That's a little easy because it's got a common denominator, but, you know, start you off with an easy one. Amelia, can you help me with this first one, just to get people one last answer before I stop the video? Sure. Yep. Yep. That's all there is to it. The tops get added, the bottom stays the same. What do you have to watch out for? When there's a negative, because then people forget to distribute the negative. So in question 2, that's just to multiply fractions. Question 3 is just to multiply fractions. Don't even need common denominators there, but if you can factor it, you should. So watch for chances to factor stuff. Okay, this was problem 1 actually, not an A. And that's all I have for the video for today. Watch for an answer key to get posted later, and then the test is tomorrow.